Bismillahirrahmanirrahim. Uh, Welcome to our first lecture on electronic engineering. So, in this course, as I have discussed before, we will be in the introduction part. As I discussed in the introduction part, we will be studying about the electronics. So, you have to follow the textbook. First of all, I will give you the details of the textbook. So you have to follow the textbook. It's very important. Okay, you have to use the textbook by Thomas L. Floyd, and this is one of the very famous textbook in this field. That is the name of the textbook is actually Electronic Devices, and the author is Thomas L. Floyd, and it is by the Prentice Hall publication. Okay, and I will give you some reading assignments based on this. Okay, reading assignments based on this, and this reading assignments will be based on the 7th edition. Actually, the 7th edition of the textbook. The reading assignments will be based on the 7th edition of the textbook. It will be based on the 7th edition of the textbook, and the same textbook. Okay, the same textbook, 7th edition of the same textbook. I will give you the page number. Okay, I will give you the page numbers for reading. Okay, so you can see here you have to follow the textbook by the author Thomas L. Floyd, and the name of the textbook is Electronic Devices. Okay, now we have something like other reference books that you can have. Reference books. Okay, it is by the author Robert L. Boylston. Okay, Robert L. Boylston, and Louis Nashelski. Okay, and the name of the textbook is Electronic Devices and Circuit. Electronic Devices and Circuits, and you can see this everything is everything is correctly given in the course description. Okay, so we will start our course. You can have so the name of the course is actually Electronic Engineering. So first of all, electronic engineering. So first of all, we will see what is electronics. So I hope that you may know this terminology. So electronics is the word actually derived from electron plus mechanics. And you know the electron, it is one of the fundamental particle actually which you can see in an atom. Basically, atom consists of 3 particles: proton, electron and neutron, and electron is one of the particle, and it is a charged particle in the atom. You can see it is the charged particle which is revolving around the nucleus of the atom. It is a charged particle. And basically it is having negative charge. The charge of the electron is actually negative charge, and electron is the basically a negative charged particle of the atom. And the mechanics. What do you mean by the word mechanics? The word mechanics is basically deal with the study of the motion. Okay, so mechanics is the basically related to the motion of the electron. So you are talking about the electron. So electron plus mechanics means you are basically talking about the motion of the electron. So basically it is meant by the motion of the electron. So basically how you can control the motion of the electron. So for controlling the motion of the electron, you need a special kind of devices. You may need some special devices, and these devices we will call as the electronic devices. Okay, so in this course we will study about in this course you will study about the electronic devices. I am talking ED means electronic devices. Okay, and some circuits also. You may also study about some special kind of circuits which are designed to control the flow of electron. So electronic devices are the devices which are used to control the motion of electrons. So electrons, this is the symbol for electron. Okay, don't forget this one. It is the symbol for electron. That means E with a negative sign on the top, you can say this is the charge of the electron. So this is showing the charge, negative charge, and this is for electron. So electronic devices, and we need some special kind of circuit by using electronic devices. By using electronic devices we have some circuits also, and these kind of circuits we will call electronic circuits. Okay, so by using electronic devices we have some kind of circuits, and those circuits we will call it as electronic circuits. Now we will just brief something about the history of the electronics. To control the flow of electrons or to control the motion of the electron, we need electronic devices. Previously in 1920s and all, actually we were using some other kind of devices which were used to control the flow of electron, and those devices basically one of the main component in those devices is actually the vacuum tubes. Okay, but currently we are not using it. Now we are not using it anyway. I will explain it later. So vacuum tubes were the one of the major component, and after a long time actually people invented a new there was a new breakthrough by the invention of transistor in 1947 by the three scientists. Okay, these three scientists actually made the transistor, which is now known as the transistor. Actually this transistor by using the semiconductor device. Now this has been replaced. We replaced this guy. That means the vacuum tubes replaced by the semiconductor devices. Nowadays we are using the semiconductor devices. Okay, semiconductor devices. So I will explain to you about semiconductor devices later. So by using semiconductor is a special type of material. It is a type of material anyway, which is having some particular property. So we are using semiconductor devices nowadays. Okay, now we are using semiconductor devices. So by using semiconductor devices, we made many electronic circuits, electronic devices. By using electronic devices, we made many electronic circuits also. And basically many applications are there for the electronic devices and the circuits. One of the important application, you can see it is in the radio, okay, in the television, then you can see some applications like the phonographs in the olden days. Actually nowadays we cannot see it, it's one of the old device. Okay. Then we are using it in radar, computers, okay, and telephony, mobile communication. So many applications are there. There are a lot of application for the electronic devices and circuits. So basically all the electronic devices are manufactured by using a special kind of material which is known as the semiconductors. Okay. So what are the different types of electronic devices? Different electronic devices. Some examples. Okay, I will give you some example. One of the important device is nothing but the diode. Okay, we will call it as diode. Okay. Next, another one is known as the transistor. Okay, transistor. And another one we call it as integrated circuits. So these are the basic electronic devices, integrated circuits. So what is the diode? Actually diode is a semiconductor device. All are semiconductor devices. Semiconductor device with two connections. Okay, it is having two connections. So you can say there are two connections for this device. And transistor is also a semiconductor device. It's also a semiconductor device with three connections. Okay. And this is also again, that is the integrated circuit is also again a semiconductor device with many transistor. Actually this is also a semiconductor device. Okay. And it contains, actually it is a combination. It contains the integration means, you know, summing up, that or like that you can say it is a chip. You can say, we will call in general, in layman language, we will call it as chip also. Another name for this is chip. You might have heard about the i7 processor, i5 processor, Intel, Pentium. All this are chip, actually integrated circuits. So it contains many devices. After combining many electronic devices actually in a single chip, then we will call it as the integrated circuits. Nowadays many advanced technologies are available to make the integrated circuits. Okay. So first of all, before going to explain the semiconductor materials, we will talk about what are the different types of materials available in the nature. Okay. So we can first of all classify the materials. The materials in nature can be classified into three types basically. The first type are the conductors. The second type, you can say the second type is the insulator. The third type we will call, actually the third type is nothing but the semiconductors. I think you might have heard about all these things. Semiconductors might not be semiconductors. Sometimes you might have heard about the conductors and insulators. So what are the conductors? The conductors can conduct, actually they can conduct the electricity. They will conduct electricity, okay, and also heat also, okay, basically we can say. And insulator can't conduct. Okay, insulators are the devices which can't be conduct, and semiconductors are the devices in between these two, between conduction, between the conductors and insulators. That means they will conduct only if some conditions are met. Anyway, insulators, okay, so we will explain about it later. So you can give some examples for the conductors. What are the conductors? You know, the iron is a conductor. That means your hadid, actually iron. Then the copper, okay, aluminum, okay, it will easily conduct. Then silver, then you know gold, all are conductors. And what about the insulator? Insulators, you can give some example like your wood, the plastic, etc. And for the semiconductors, the examples include the silicon, okay, it is extracted from the sand, silicon, germanium. So usually the symbol for the silicon is Si, okay, germanium, that means Ge. Then another is the gallium arsenide, okay, gallium arsenide, okay. So what I want to tell you is that out of this silicon and germanium, both are elements. What do you mean by element? Both are elements. And this gallium arsenide is not an element, it is actually a compound. So what do you mean by compound and element? Element means it contains only one type of atom, right? Element means it contains only one type of atom. That means if you take silicon or germanium, it contains only one type of atom. That means it contains either silicon or germanium, you can say. In silicon, it will contain only silicon. In germanium, it will contain only germanium. But if you take a piece of gallium arsenide, you can say that it is a compound. That means it contains both gallium, that is your Ga, and it contains the arsenic. Arsenic is your As. So it is a compound. It contains two types of atom. That's why it is known as the compound. So there are three types of materials. I am going to conclude this part. That means we have conductors, insulators, and semiconductors. The conductors will conduct the electricity, and some insulator will never conduct the electricity. But there are some conditions, inshallah, that will explain later. But semiconductors are something in between the conductors and insulators. Okay, so that is about the conductors and the insulators. Next, we will talk about the energy levels of these different types of materials. So I am going to explain what do you mean by this energy level. Energy level. You know that first of all you should know what is the Bohr's model of the atom. So I am talking about now the Bohr's atom model. So you know that atom has three things. That is, first one is the nucleus. That means nucleus, it contains the proton and neutron. Okay, it contains the proton and neutron. Okay, and around this there are some orbits, you can say, and in this orbits the electrons will be moving. the electrons will be moving around this orbit. Okay, the electrons will be moving around this orbit. The electrons are moving around this orbit. Okay, this is the electron, for example. So electrons will be moving around this orbit. So this is the Bohr model. So you have an atom with electron. Actually, basically you have electron, then you have a proton, and you have a neutron. Okay, so what is the charge of the electron? I have told you the charge of the electron is minus or negative, you can say, and the charge of the proton is positive, and the charge of the neutron is 0, or you can say it is electrically neutral. It does not have any charge. Okay, so we are talking about the energy levels. Now these are the three particles, we can say three things in the atom. Now you can say that the atoms in this outermost level, we can say this is the outermost level, this is the outer level. Let's say this is the outer level. You can say this is the outer part of the orbit, outermost level. So that means the atoms in this, the electrons in this outermost level, or we will call this is the outer shell or orbit, you can say. The electrons in this orbit, we will call these electrons as the valence electrons. So the electrons in the outer shell is having another name. It is also known as the valence shell. Okay, it is also known as the valence shell. So you might have heard about it, I don't know, anyway. Valence shell, have you heard about the term valency? So it is also known as the valence shell. Okay, outer shell is also known as the valence shell. So the electrons in the outermost shell is known as electrons in the outermost shell is also known as valence electrons. Okay, valence electrons. So you can say that, you can see here, these electrons in the outermost shell are loosely bounded. You can see they are very far away from the nucleus. They are a little bit far away from the nucleus. So they are loosely bounded. The force of attraction between, you know that the nucleus is positive charge and the electron is negative charge. So there will be a force of attraction between the nucleus and the electron, and you can say that there is a force of attraction between the electrons and the nucleus, and they are loosely bounded, means since they are far away from the nucleus, the force of attraction will be comparatively low. So since electrons, this is electron, okay, electrons in the outer shell are far away from the nucleus, the force of attraction between them and nucleus is comparatively less. Okay, comparatively less, it is less. Okay, comparatively less. So this is very, very important point you have to note down. So since the force of attraction between the electrons and the nucleus is very less, if it is very less, for example, I will draw it again here. This is your nucleus, and this may be your electron in the outermost shell. This is the electron in outer shell. So the force of attraction between these guys can be represented like this. This is the force of attraction. This is positive charge and this is the negative charge. And you can see the radius is r, and we can give the force of attraction as 1 by 4 pi epsilon into this charge. Let's say this is q and this is e, then it's q into e by r square. you can see that the force will decrease as you increase the R. You can see if you increase the R, then the force of attraction will decrease. Since they are very far away from the nucleus, comparatively they are far away from the nucleus, their force of attraction will be less. So when the force of attraction is less, if you give an external field to that, for example, you have a material like this, okay, and you have a nucleus here, this is your nucleus, and there is an electron here, and if you are giving an external voltage to this guy, you can see here if you are giving a positive here, negative here, this is big one is positive and small one is negative. That is the symbol for the battery. Okay, this is a battery. So if you are giving some potential here, you have an electric field like positive here and negative here. Okay, then what will happen? The charge of the electron is negative because of this, and this force of attraction between these two guys are less weak, or say it's weak. What will happen? Due to this electric field that you have given externally positive, the electron will try to jump away from the atom and it will try to move. So the electron will move like this, and whenever electron moves, you will have a flow of electrons. Maybe a lot of atoms will be there in a material, so you will have a flow of electron, and this flow of electron at unit time, that means the amount of charge moving at unit time, it is known as, the total charge will be N into E. For example, N is the number of electrons, or Ne I can say. Ne is the number of electron. Okay, Ne is the number of electrons. So whenever a lot of electrons move, then you have this much charge. This is the total charge which is moving. And the number of electron which is flowing per unit time divided by time, and we will call this is the current I. So the current I can be written as, you will be having a current, and you will be having a current which is Ne into E divided by this T. Okay, where E is the charge of the electron. You can say this, I will represent like this. So E is the charge of the electron. And what is the charge of electron? The charge of electron is equal to 1.6 into 10 power minus 19 coulombs. This is the charge of the electron approximately. So the amount of charge which is moving in unit time, it is known as the current. So you may think that the current will be moving in this, the current direction will be like this. No, the current direction is not like this actually. We will be representing the current direction in the opposite way. It is because we will be representing the current direction in this way. Even though the electrons are moving like this, the current direction is opposite. It is because the electron are having negative charge. That's why we are assuming like this. The current is defined in such a way that it is the movement of the positive charge, but there is no positive charge to move. So the electrons that we are talking about is moving in the opposite way. So the actual direction of the current will be opposite to the flow of electron. So the current I is having a direction which is opposite opposite, you know, it is X in Arabic, you can say. It is opposite to the movement of electron. Why we are assuming like this? It is because the charge of the electrons, because the charge of electron is negative. Negative is usually represented by a minus sign with VE, that means negative. Okay, the charge of the electron is negative. That is the reason. So if the electron is very far away from the nucleus, you can say here, I have already told you, if the electron is very far away from the nucleus, the force of attraction will be less. Then the chance for moving away from the atom is more. So if R is very high, the chance of moving away from the atom is very high, you can say. So this guy can easily move very high if we apply even a small voltage. So even though if you give a small voltage, the electrons will try to jump away from the atom and it will try to move. This is the situation in your conductor. So we can say this is the situation. This is the situation. This is the situation in a conductor. So what may be the situation in a? So in a conductor, you have a nucleus, the electron is very far away, and the force between these guys, positive and negative, is weak attraction. Okay, weak attraction. So whenever you apply a voltage, this guy will jump away from the atom and move it, and it will move like this. Okay, this is the situation in a conductor. Then what will be that means the energy of electron in a conductor is more, right? This is the situation of the energy of electron in a conductor. However, so this is the situation of energy of electron in a conductor. So that's what I am saying about the conductor. Now what about the insulator? Energy of what electron? What I am saying, which electron? Energy of valence electron. Okay, we are talking about the valence electron. Valence means electrons in the outer shell. So this electron which is in the outer shell, if you give some voltage to them, they will get some more energy and that they will easily jump away from the atom. Okay, that is the situation in a conductor. In an insulator, if you take the situation, you can see here, this is your nucleus, maybe the electron will be very close. Since they are very close, or the force of attraction between them is very high, the force is very high, force of attraction is strong. The force of attraction is strong. So because of this, the force of attraction is strong. Because of it, this electron cannot easily move. Electron can't easily move with small or high voltage. But if you give very high voltage, there is a chance that electrons will move in a conductor too, sorry, in an insulator too. So but even with a small or high voltage, these guys cannot conduct. You can say the example is in plastic. And semiconductors are the devices. The semiconductors are the devices which is showing the property something in between the conductors and insulators. So semiconductors are having, you have a nucleus, the atom, the electron will be here, nucleus is positive, this is negative, and it will not easily move unless you give a little bit high voltage. Okay, so it will show the property between, this is the symbol for between, okay, between the conductors and insulators. So these guys will show the property which is between the conductors and the insulators. Okay, so we are going to draw the energy diagram for this semiconductors, conductors and insulators. So first of all, I will draw the energy diagram. energy diagram. So energy diagram will show the energy of electrons in the conduction band or the valence in the outermost shell, okay, in the outermost shell or the valence band. So we will see first of all regarding the insulator, okay. So what about the insulator? So we will see here, this is the diagram. So you have a valence band. So valence band, this is an energy diagram, and you can say when you move up you are increasing the energy. Actually the energy is more, and if you are on the top, on the bottom, the energy is less. And this is showing the valence band. Valence band means the energy of the electron in the outermost shell. So you have an electron, you have a nucleus here, you have an electron here, and you have a force of attraction between the electron. And how much energy is there for this guy? That means energy of the electron in the outermost shell. That is what it is showing. So this is the valence band. But that energy is not enough to move away from the nucleus. If you give a supply voltage, then sometimes it will move. But you can see here, the conduction band is here. That means this is your conduction band. This is your conduction band actually. That means the energy difference between the conduction band and the valence band is very, very high. And this energy gap we will known as, it is known as the gap actually, energy gap, okay, G for gap. This energy gap is greater than 5 electron volt usually. Then we will call it as a insulator. Now we will see what is the situation of a conductor. It's okay, this is not required here, right? So then we will see what is the situation in a conductor. So we will talk about the conductor. In a conductor, we will draw the same thing. This is the energy, and you have a valence band which is much above actually. You have the valence band is somewhere here. This is your valence band. So this is your valence band, okay, and your conduction band is somewhere here itself. Your conduction band is somewhere here itself, conduction band. So you can see here your conduction band is here and the valence band is here, almost at the same level. That means if you give a small voltage, the valence band electron will go for the conduction, or it will move immediately to the conduction band. That means if you give a small voltage like millivolts, the electrons will move or jump away from the atom and it will constitute a current, right? That is the situation. Now we have another thing which is known as the semiconductor. Here we are focusing on semiconductor. So in the semiconductor, actually we are going to draw the energy diagram. This is your energy, okay, and your valence band will be somewhere here anyway. This is your valence band, and your conduction band will be somewhere here. Your conduction band will be here. So this is your conduction band. That means you can see here the energy gap between these two guys is very less, okay, when compared to the previous thing, that like insulator. And in conductor, actually, what is the energy gap? The energy gap is approximately, you can say it is zero, almost zero. There is no gap between them, almost same. But here there is in the semiconductor, there is a gap actually. So what are this gap? And this gap will be equal to approximately energy gap in semiconductor like germanium. The energy gap is 0.67 electron volt. This is in the case of germanium, okay, and this energy gap will be 1.1 electron volt in the case of silicon, that is a semiconductor, okay, and this energy gap will be 1.43 electron volt in the case of gallium arsenide. So you can see here, in a insulator the energy gap is 5 electron volt, greater than 5 electron volt, but in semiconductor it is a small number like 0.6, 1.1 and 1.43 like this. Okay, so you can say it is less than 2 anyway, always. But in a conductor there is no energy gap. Okay, so in a conductor, since there is no energy gap, if you give even that means the electrons are at higher energy level, even though it is in the balanced band, they are having higher energy level in the case of conductors. So if you give a small voltage, directly they will go for the conduction. Okay, so they have high energy which is required for the conduction actually. So if you give a small voltage also, it will conduct. But in the semiconductor you have the conduction band, and this conduction band is having and the valence band is having a small energy gap in semiconductor, but in insulator the energy gap is very large. So this is the property. So first of all, okay, that's it. Now we will see, you can see that I have used a unit which is known as electron volt. So what is this electron volt? Electron volt, I have used the energy gap is equal to is greater than 5 electron volt in insulator, and energy gap is equal to, let's say, this 0.67 electron volt in germanium. So I have used like this. Okay, germanium. So what is this electron volt? So electron volt is the unit of energy actually. It is the unit of energy. Okay, so you know that the unit of energy is, another unit is there for the energy, another unit, it is known as the joules. Okay, energy is having another unit, but electron volts is also another unit for the energy. So what is this electron volt? What is 1 electron volt? 1 electron volt means 1 multiplied with the charge of the electron. You can see this is the charge, 1.6 into 10 power minus 19 is the charge of the electron, and you can see this is 1 volt actually into 1, that means this is 1.6 into 10 power minus 19 joules. So 1 electron volt means what? It is nothing but 1.6 into 10 power minus 19 joules. So what is 10 electron volt? For example 10 electron volt means 10 multiplied with 1.6 into 10 power minus 19 joules. That means 16 into 10 power minus 19 joules. That is the 10 electron volt. Okay, so 1 electron volt means it is having an energy, it is nothing but 1 electron volt is the unit of energy, and it is nothing but 1.6 into 10 power minus 19 joules. So that is it. So we have talked about the energy band diagram. Okay, this is also known as energy band diagram, or energy band diagram, energy band diagram. Okay, so we have different types of materials like conductors, insulators and semiconductors. So for making electronic devices, for manufacturing electronic devices, we will use the material which is known as semiconductors, the materials which is having a property which is known as the semiconductor property. Okay, semiconductors. And what are the different types of material? The example are silicon. Okay, don't forget this. That is known as Si. Okay, silicon. Then another one is known as the germanium. Okay, germanium. Then another one is the gallium arsenide. Okay, which is known as the gallium arsenide. gallium arsenide. So these are the different types of materials that we are using. Okay, germanium is Ge. So these are all used to make the electronic devices, for making electronic devices. There are some other materials also which are known as gallium arsenide phosphide, like gallium arsenide phosphide and all. Okay, so basically you should understand these are the different types of materials, that is the silicon and germanium. So we will be mainly focusing on the silicon and germanium. Okay, and one of the advantage of this gallium arsenide, actually arsenic is a poison, so you can see this is using in many electronic devices. So never throw this kind of semiconductor things or devices into the ponds or rivers or sea. Okay, you should be very careful about this. So gallium arsenide is one of the device which is used in high speed switching and all. So the speed of operation is high if we use this material. If you want to manufacture the electronic devices with high speed of operation, sometimes you have to use this. Okay, so what is the atomic number for the silicon? The atomic number for the silicon, that means the An for the silicon, you can say it is 14, and for this germanium it is 32. Okay, so don't forget this. So inshallah in the next class we will explain why we are using silicon and germanium and what are the properties and what is the crystalline structure, everything in the next class. Okay, thank you.